Very good morning, students. Welcome to online practical series by LJ Institute of Pharmacy. I am Dr. Jignesha, working as professor in the Department of Quality Assurance at LJ Institute of Pharmacy. Today we will be focusing on the practical of UV visible spectroscopy. We have already gone with the theory of UV visible spectroscopy during our theory classes. The contents which we will be going through today in the practical will be the principle of UV visible spectroscopy, followed by demonstration of UV visible spectrophotometer. We have gone with the electromagnetic spectrum during our theory classes, where we have gone with different kinds of radiations. So here we will go with a brief insight over the UV visible radiation. UV visible radiation is a part of an electromagnetic spectrum. UV radiation, it ranges from 200 nanometer wavelength to 400 nanometer wavelength, and visible radiation, it ranges from 400 nanometer wavelength to 800 nanometer wavelength. If you compare the energy of UV radiation and visible radiation, then UV radiation, it possesses higher energy, and visible radiation, it possesses lower energy. The visible spectrum, it possesses all the radiations which are visible to naked eyes, whereas UV visible in case of UV spectroscopy, the UV radiations are not visible to our naked eyes. UV spectroscopy, in that case, UV radiations are most commonly used to analyze the compounds which are colorless and clear solutions, whereas in case of visible spectroscopy, it is mainly used to analyze the compounds which are colored in their nature. So as we have gone with the wavelength of both the radiations, UV radiation, it ranges from 200 nanometer wavelength to 400 nanometer wavelength, and visible radiation ranges from 400 nanometer to 800 nanometer wavelength. This entire UV visible spectrum, it will extend from 200 nanometer to 800 nanometer wavelength. Visible spectroscopy, it is also known as electronic spectroscopy because it involves electronic transition, and it is also known as absorption spectroscopy because here absorption of the UV visible radiation will take place by the sample. First of all, going with the theory of UV visible spectroscopy, as I have told that it is also known as electronic spectroscopy because it involves electronic transition from ground state to higher energy level. There are organic compounds which will be either containing sigma bond, pi bond, or n electrons. The compounds which contain sigma bond has sigma electrons. Compounds which are containing double bond and triple bond, they are associated with pi electrons, and compounds which are having non-bonded electrons, that is lone pair of electrons, they are not associated with the bond formation. So these compounds, they constitute the electrons present in any particular molecule. Absorption of the radiation by a particular molecule, it takes place because of the presence of chromophore in the compound. So if a chromophore is present in the compound, then only the absorption of the radiation will take place. If chromophore is not present in the compound, then the absorption of the radiation will not take place. We have already gone with different examples of chromophore, where I can say that conjugation is one example of a chromophore which is present in benzene ring system. Now absorption of the radiation, it leads to transition of the electrons from ground state to higher energy level. So the electrons which are present in the outermost orbital in a particular molecule will absorb the radiation, and they will undergo transition from ground state to a metastable state. Now every molecule, depending upon the electrons which are present in that particular molecule, is associated with a quantum of energy. Now every electromagnetic radiation is also associated with some definite energy. Now when the radiations which are imparted to the molecule, if the energy of the radiation, it matches with the quantum of the energy of the compound, in that case the absorption of the radiation will take place. This mechanism of the absorption of the radiation by a molecule, it plays a very important role in analysis of the compounds in UV visible spectroscopy. Now when UV radiations are being provided to the molecule, and when this frequency, it coincides, in that case the absorption mechanism will take place, that is the absorption of the radiation by the sample will take place. we are mainly associated with determining that how much amount of the radiation has been absorbed by the molecule. That is the basis of our practical. So absorption of the radiation leads to excitation of the electrons from ground state to metastable state. There are different types of electronic transitions which takes place. The first type of electronic transition is sigma to sigma star transition, followed by n to sigma star transition, then there is pi to pi star transition, and last one is n to pi star transition. If you compare all these four transitions, then sigma to sigma star transition, it is associated with highest energy, while n to pi star transition, it is always associated with lowest amount of energy. Most common type of transition which is found in case of UV visible spectroscopy is pi to pi star transition. Now moving towards the procedure which is involved in analyzing a compound by UV visible spectroscopy, as I have told that it is one kind of absorption spectroscopy, and the basis of our experiment is how much amount of the radiation has been absorbed, that is to be determined. Now before analyzing the sample, we will nullify the blank solution. Nullification of blank solution, it is necessary to nullify any kind of absorbance which is taking place by the impurity present in the solvent, so that the solvent which is used for preparing a solution, that will not interfere with the analysis of the sample. Now the electromagnetic radiations, they are allowed to pass through the sample. Now as the sample contains chromophores, depending upon what kind of structure is present in that compound or what kind of bonds are present in that compound, characteristic radiations from the EMR will be absorbed by the sample. The radiations, after absorption, the radiations are transmitted, and the transmitted radiation will move towards the detector. Now detector will analyze the transmitted radiation. Depending upon the amount of transmitted radiation, by reverse calculation we will determine that how much amount of the radiation has been absorbed. Chromophore and oxochrome will play a very important role in the absorption of the radiation. After getting absorbance of the sample, we will be plotting a graph of absorbance of standard solutions versus wavelength, and we will plot a graph. Depending upon the graph, we will identify the lambda max of the compound. Lambda max, it is the wavelength at which maximum absorption of the radiation takes place. This wavelength is mainly used for the analysis of the compound. For every particular molecule, it has its own different lambda max. This lambda max value for a particular compound, it will be acting as a fingerprint for that compound. That's why we use lambda max value as an identification tool for the compound, and hence lambda max finds qualitative application in the field of analysis. Means what kind of compound is present in a given sample, that can be analyzed by the lambda max. So lambda max will give us an idea that what kind of compound is present. Now absorption of the sample, once it is determined at the lambda max wavelength, then we will go through the calculation part. Here there is a diagram of a double beam UV visible spectrophotometer, as well as there is a diagram of a graph which shows us the lambda max of the compound. Now as we have gone in theory classes, that in case of double beam UV visible spectrophotometer, it has an advantage that both sample as well as reference solution can be analyzed simultaneously. As a result, the nullification of the blank solution will simultaneously take place along with the analysis of the sample. So this offers a unique advantage in case of double beam UV visible spectrophotometer. The diagram of the lambda max which has been shown below, there you can see that at 217 nanometer maximum absorption of the radiation is taking place. This particular wavelength, it is used as a tool for the analysis of the compound. So this is how every compound have their own lambda max, and which is used as an identification tool for that compound. Now after determining the absorption of the radiation, using Vis and Lambert's law equation, we can determine the concentration of unknown sample. As we have already gone with Vis and Lambert's law equation, the equation is A is equal to epsilon Ct, where capital A is the absorbance of the solution, C is the concentration of the sample, T is the path length, and epsilon is the molar absorptivity of the compound. Now here A is equal to epsilon Ct equation, the path length will remain constant, because the length of the cuvette will be always constant in which we are taking the sample and in which we are analyzing the sample. Length of the cuvette will not change. That's why path length will always remain constant. In our case, T is 1 centimeter. Now, if we know the value of absorbance and if we know the value of molar absorptivity of a compound, we can determine concentration of any unknown solution. So, this is how this particular equation will help us to identify the concentration of the compound. So, it plays a very important role in assay of drug substances, that is determining the percentage purity of drug substances and drug product. Also, this equation finds application in monograph analysis of the compound, performing monographic assay. Impurity identification and impurity analysis can also be done by UV visible spectroscopy, as well as UV visible spectroscopy finds a wide application in analytical method validation also. So, this particular principle and procedure, it finds a wide application in pharmaceutical industry also. In the next session, we will go through the demonstration of the instrument, that is UV visible spectrophotometer. Thank you.